We are working on trigonometry. So, this first one says, find the terminal point on the unit circle determined by 5 pi divided by the square root of 6. So, all of these unit circle problems are going to be based on one of two triangles. And you can memorize the triangles if you want. I haven't memorized them. But if you memorize a piece of the triangle, it's actually really easy to fill out the entire triangle. So, here's what the unit circle looks like. It's called the unit circle because the radius is 1. 1 what? We don't care. No matter how big your circle is, you don't even need to measure it. Whatever it is, we just call it 1. And then all this trigonometry works out. So, if I take that unit circle and I put 24 tick marks in the entire circle. So 1, 2, 3, 4, 5 in each quadrant. And you take those and then you have the ordinate points. There are 24 of them, evenly spread. Now, we're going to go through and get rid of those. Okay. So, now I have 3 marks in every quadrant. Okay? Well, let's figure out what these marks are in radians. So 2 pi, this is pi over 2, and this is 3 pi over 2. So if there are 24 marks, how big is each mark in terms of pi? 1/12. Okay? So this one here would be 1 over 12, but we're skipping it. The next one would be 2 over 12, which is also known as pi over 6. The next one would be 3/12, which is pi over 4. And the next one is 4/12, which is pi over 3. And then we skip 7, and 8, or not 7, we skip 5, and 6 is going to be pi over 2. Okay? Well, if this angle is 1/4, then this angle would be 2/4, and this angle would be 3 pi over 4. What would this one, nope, wrong one. What would this one be? 5 over 4. And what would this one be? 7 over 4. Does everybody understand that? So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, which simplifies to 3 over 2, 7/4, 8/4. Does that make sense? Okay. So we can do the same thing with sixths. So 1/6. Well, let's do it this way. This will make more sense. So this is 1/6, and this is 1/6. So what goes there? 5 pi over 6. Does everybody understand that? It's 1/6 short of 1. So this one would be 5 pi over 6. Okay? Well, what's this one? It's 1/6 more than 1. So 7 pi over 6. Okay? Well, what about this one? It's 1/6 short of 2. And 2 is 12 over 6. So 1 short of that would be 11 pi over 6. Okay? Now, the last one is in thirds. That's a third. So that one would be 2/3. That is 3/3. This one is 4/3. Five thirds, and then 6/3. Okay? So, now I need to, this is going to take a while. Sorry, guys. Forget it. Forget it. What if I did the same thing in degrees? It's going to be 30, 45, 60, and then we have 90, and then we go 30 more, that's a 9, which is 120, 135, 150, and then from 180 we go 30 more, which is 210, 225, and 240, then 270, plus 30 is 300, 315, and 330. Okay? Well, if the radius is 1, what is the coordinate of this point? Well, we need to build a triangle that has 1 on the, the hypotenuse is 1, and this angle is 30 degrees. And we're going to do this in radians here in a second, but we had to start in degrees. It makes a little bit more sense. Well, it turns out that you're going to have a short side and a long side. So which one is shorter, A or B? Why A? Well, let's look at the angles. A is created by a 30-degree angle, and B is created by a 60-degree angle. And when you have a bigger angle, you have a longer side. So, one of these sides is 1/2, and the other one is the square root of 3/2, which is about 0.86. I could show you how to get those, but it's really not worth your time. Okay? So this point right here is root 3/2, comma 1/2. Because I go over 0.86 and up 1/2. Okay? What about this triangle? How big are those going to be? They're actually equal. And I could show you how to solve for them, but it's not worth your time. It's the square root of 2/2. Okay? So this point here is root 2/2, comma root 2/2. What about the next one? It's the same as the first one. Do you see that? So if you look at this triangle, we have a short side and we have a long side. So now it's 1/2, comma root 3/2. Okay, and then the only other thing you need to know is this point is 1, 0. This point is 0, 1. This point is -1, 0. And this point is 0, -1. With that information, this is called the unit circle, all of these points. You can figure them all out without a calculator. So, let's go here. What is the point at 5 pi over 6? Well, where does 5 pi over 6 land? It's in second quadrant. Is it close to the x-axis or close to the y-axis? Closer to the x. So, right here. Okay? Well, it's a unit circle, so this is 1. What is the length of the x-axis right there? Is it the short side or the long side? The long side. So this point, the x-coordinate is going to be negative root 3 over 2. And then what is the y-axis coordinate? 1/2. So those two numbers always go together. The only thing you need to decide is which one's first, and are any of them negative? Does that make sense? Okay, what if I said 7 pi over 4? Where is that? It's in quadrant 4, closer to the x or closer to the y? It's in the middle, right? Because in fourths, 1/4, 2/4, 3, 4, 5, 6, 7. It's right in the middle. And for the ones that are right in the middle, it's root 2 over 2, comma, root 2 over 2. We just have to pick the signs. What is the value of x in quadrant 4? Negative. What's the value of y in quadrant 4? Negative. So it's negative root 2 over 2, comma, negative root 2 over 2. Okay. What about 4 pi over 3? What quadrant are we in? We're in quadrant 3, and it's one of these three angles. Which one is it? So we're doing thirds. 1/3, 2/3, 3/3, 4/3. Right there. Do you guys see that? Now we draw the triangle. And we know it's either 1/2 or root 3 over 2. Is the x-coordinate the short side or the long side? Short side. So it's going to be 1/2, comma, root 3 over 2. Oh, I did my negatives wrong in the last one, didn't I? Nobody said anything? Sorry. Okay. So, yeah, in the last one, the x value should have been positive. I'm sorry. Does that make sense? Okay, what about this? What about 15 pi over 6? What quadrant does that land in? Well, let's count. How far to there? 6, 12, 18. So it's somewhere between 18 and 12. Oh. It's this right here. Now I cheated a little bit because it actually simplifies. But right there, if that's a unit circle, what is the point? 0, 1. Okay, because 15 is halfway between 12 and 18. Okay. What if we do negative 11 pi over 4? So let's count. 4, 8, 12. I didn't make it to 12, so I'm going to be right here. If that is my circle, what is this length there? Negative root 2 over 2. And what is this length here? Root 2 over 2. Okay? Now, you want the good news? I'm going to give you a circle with all the numbers on it. Yes. You will get your own. Today I'm just going to put it up on the board, but see this unit circle right here? It's got all of those numbers on it. So you just need to figure out where it lands, and then you'll have the numbers. Okay. So, next problem. So, what is the sine of 7 pi over 4? So, in my unit circle, and again, there will be one up on the board, 7 pi over 4 is right here. And that is, let's see if I can get it right this time, root 2 over 2, comma, negative root 2 over 2. Okay? So, grooving out. So, here's my angle here. That angle is 7 pi over 4. Right? Which, we've never built triangles that had angles that were that large before. So what we do is, we draw the angle, and then our triangles always connect to the x-axis. So in quadrant 1, the triangles would look like that. In quadrant 2, the triangles would look like that. And in quadrant 3, they look like that. Your triangles always connect to the x-axis, not the y-axis, the x-axis. Okay. So this is asking, what is the sine of 7 pi over 4? Well, sine is opposite over hypotenuse. So in this triangle, what is the length of the opposite? And what's the length of the hypotenuse? 1. So what is negative root 2 over 2 divided by 1? It's just negative root 2 over 2. Because sine is O over h, but h is 1. So in this case, sine will always be the opposite, or the y value. That's why the unit circle is so nice. If we call the hypotenuse 1, then the sine value is just the y coordinate. That's it. So if I asked you, what is the sine of 90 degrees? What is the y value at 90 degrees? One. So in the unit circle, sine is always the y, cosine is always the x. And tangent is just going to be y divided by x. All right, so if I said, what is the cosine of 5 pi over 6? Where is 5 pi over 6? It's in 2. Right there. Okay? For that point, am I going to do the x or the y? Well, here's how I remember it. Cosine equals x, sine equals y. They're in alphabetical order. Cosine comes before sine alphabetically. X comes before y. So what is the x value of this point? How far left are we? Root 3 over 2. You only have 3 choices. It's either 1/2, root 2 over 2, or root 3 over 2. Okay? The root 2 over 2's only happen on the fourths, in the middle. The 1/2 is a shorter one. The root 3 over 2 is a longer one. So in this case, the x-axis is long. So the answer is negative root 3 over 2. Can you guys remember that? All right. Suppose that theta is an angle in standard position and it ends at negative 12 over 37, comma, 35 over 37. Where is that? Where is this point? Quadrant. The only one I didn't hear was 1. So we're going to go left and up, which puts us in 2. So I'm somewhere in quadrant 2. Right? Do I know anything about that quadrant? Well, so this is the cosine, and this is the sine. So this is A over H, and this is O over H. So how long is my hypotenuse? 37. Okay. How long is my x value? Close. Negative 12. And my y value is 35. Do you see that? So, what is the tangent of that triangle? And again, this is my theta right here. The tangent is going to be 35. It's probably going to be this. Negative 35 over 12. I'm not sure if they want you to put the negative on top or out on the front, but don't put it on the bottom. I'm sure that's not going to be correct. Okay, what is the cosine of that angle? Cosine is A over H, so negative 12 over 37. Okay, and then remind me what the cosecant is. The cosecant is the upside down version of sine. So the sine would be 35 over 37. So the cosecant would be 37 over 35. Okay, you want to see more of those? Let's do more. Let's see, that was number 3. Nope, 7. Okay. What quadrant are we in? We're in quadrant 4. We're going to go right 5, down 12, with a hypotenuse of 13. So this is my angle. What is the tangent of that triangle? So tangent is opposite over adjacent. So negative 12/5. What's the sine? Well, the sine is just going to be the y value. It's always the y value. Negative 12/13. And the secant is going to be the cosine, but flipped upside down. So it would be 13 over 5. Does that make sense? Okay, let me see if they do one with the square root on it, because if they do, it makes our lives a little bit harder. Nope. We're good. Okay, last one. Where is this angle? What quadrant is 5 pi over 4 in? It's in 3, and it's halfway in 3, right? So this point is negative root 2 over 2, comma, negative root 2 over 2. The tangent is always y divided by x. So what is y divided by x? What is negative root 2 over 2 divided by negative root 2 over 2? It's just 1. Okay, but let me pull up a unit circle. All right, let's do the tangent of 7 pi over 6. So that would be this triangle right here. Okay, the tangent is O over A, which is going to be y divided by x. Okay, now pay attention to this because this can get a little bit tricky. So we're going to take the y value, negative 1/2, and we're going to divide it by the x value, negative root 3 over 2. How do you divide two fractions? Just flip and times it. So the bottom one gets flipped upside down, 2 over negative root 3. The negatives cancel, the 2's cancel, and I get 1 over root 3. Okay? But I can't leave that in the bottom, so I have to times it by root 3 over root 3. The top becomes root 3, and the bottom becomes the square root of 9, which is just 3. Okay? Let's do the tangent of negative pi over 3. Where does negative pi over 3 land? Well, it's going to be the opposite of that angle. So instead of going that direction, we're going to go that direction. Here's my triangle. Okay? Tangent is O over A. What is the O side of that triangle if this is my angle? It's going to be this. Negative root 3 over 2. And I'm going to divide that by 1/2 or flip it. Times it by 2. 2's cancel. And I get negative root 3 over 1, which is just negative root 3. Okay? All right, last problem. Last type of problem. What about the secant of pi over 4? Okay. Well, pi over 4 is right here. Secant matches up with the cosine. So the cosine of theta is O over A, A over H. The secant of theta is H over A. So in this case, we're looking at that number. Instead of doing A over H, I'm going to flip it upside down and put H over A. So this answer is going to be the upside down version of that. 2 over root 2. But I can't leave it like that. How do I fix it? Multiply by root 2 over root 2. The top gives me 2 root 2, and the bottom gives me 2. So the answer is just the square root of 2. Okay. What about the cosecant of 2 pi over 3? So 2 pi over 3 is right here. Cosecant matches up with The sine, oh, I did that wrong, didn't I? Was I doing pi over 3 or pi over 6 for the last one? Oh no, I did this one, huh? Okay, never mind. I did it right. I'm doing this one wrong. What is the cosecant of 5 pi over 6? So we find 5 pi over 6, draw a triangle, and the cosecant is the opposite of the sine. And sine is 1/2, so what happens when I flip that 1/2 upside down? It just becomes 2. 1 over 2 flipped upside down is just 2 over 1. So this is 2. Okay, think you can do that? I believe in you. Get to work.